Let's start today. So on Monday, we added few items to our differentiation table. And I will write the last two that we need to use. I will start with some examples. So for the ln or log functions, we had this rule that ln of box could be any expression in x, is equal to box prime over box. And the derivative of log general base b of box is, again, box prime over box, but we have to deal with the general base b. So, and that will introduce a ln b factor in the denominator. So these were the last two rules of differentiation that we had. Now we need to do some examples for these ones. Okay, I will write down some examples. So the first example is, so we are trying to find the derivative of these guys. Write the third one here. And there's also this one that I would like you to do. Find y prime if we know x cubed minus x ln y plus y cubed is equal to 2x plus 5. Okay, differentiation rule, the latest one, the one that we are trying to practice are posted up here. The examples needs just your basically start differentiating, use the previous knowledge plus these rules. And I will give you maybe 2 minutes, yes? 2 minutes at least, start working on these 3 cases. And I'm hoping that out of these 3, at least you can do 2 of them. I will have an extra time for the other last example before we introduce the new item here. Go ahead, please, 2 minutes. Don't sit quiet there, not doing anything. You either writing on the board, on the paper or your tablet something, or you're talking to someone sitting next to you, trying to figure out what to do as the first step. 2 minutes to start. 50 seconds left. first one is the easy one. In other words, this is just basically this rule here. You have ln of some function. The derivative would be the derivative of that function over that function itself. Derivative of sine x is cosine x. Derivative of e to the power x is e to the power x. And that's what you need to have. For this other one, you have this rule of if you have an expression to the power n, and you want to find the derivative, that would be n, that expression to the power 1 less. Then you multiply the derivative of that expression to what already you have there. So in this case, so if I have y equal to that, then y prime is going to be n5 box prime box to the power 1 less. Yeah, that's chain rule, power rule plus chain rule. And here now, I have derivative of x squared is 2x minus 3. Derivative of ln boxes, box prime over box. So here, box is 3 minus x. Derivative of 3 minus x is negative 1 over 3 minus x. And then you have x squared minus 3 ln of 3 minus x to the power 4. This example here, so you can do it in several ways. I think the most clear way to complete this is that I have log base 2 of something. Yes? So log base 2, the derivative, is box prime over box times ln b in the denominator. Yes? So that means that I have to find the derivative of whatever is inside log base 2, which happens to be another log function. Yes? Divided by, prime of this, prime, divided by ln of the base here, 2, times the function inside log 2 base, log of this expression, base 5. So I applied this rule one time, but this box prime itself is another log function. So that means that, well, this part I don't have anything to add to it. But this part here is that log of something base 5. Then that itself is going to be box prime 4x cubed minus 5 divided by ln of base times box. And that's what we need. Obviously, one can do some simplifications there, but again, as I have been mentioning, in differentiation examples problems, we specifically will ask, don't simplify, so that you go like that. Any questions, any comments? Are we all good? Yes? Let's work on the other example over there. To be able to do that, you definitely need what we have here, the derivative of ln function, log functions. But there is something different about the process that I need to follow to find y prime in this case. Can anyone point out what is special here? Implicit differentiation. Rather than having y equal to an expression of x, we have an equation in x and y, so we need to use implicit differentiation here. Yes? How about I give you 90 seconds? Now I want to hear some noises there, out there. Talk to some friend. Convince them or learn from them or teach them. Go ahead, 90 seconds. Thirty seconds left. Let me tell you something. You won't be able to find anything about that example in your phones. Please, do it on the board, on the tablet, or on the notebook, or at least start it. Yeah, I don't see anything. Okay, implicit differentiation. Why implicit? Because I don't have explicitly defined function. So I will go differentiate the left-hand side, differentiate the right-hand side. The key point in implicit differentiation is that when it comes to differentiating terms in y, you have to consider y as a function, so apply always chain rule version of the differentiation rule. So here, this derivative is 3x squared minus, this is product of two functions, derivative of first one times second one, minus the first one itself, derivative of second one. Derivative of ln y is y prime over y. So that is how I get this, plus y prime over y. That's how I get the second term here. Plus derivative of y cubed is 3y squared. You multiply it by y prime. And then the right-hand side, you just get 2 there, yes? Now, I can do this. I can just multiply that negative sign inside. Now, I see that this term and that term, these two have y prime. So I'll keep them on the left-hand side. I want to isolate y prime. And then take everything else to the right-hand side. So I will get y prime. There is minus x over y plus 3y squared equal, that was 2 on the right-hand side, minus 3x squared plus ln of y. And that's all I need, because the next step is basically divide the right-hand side, which was 2 2 minus 3x squared plus ln y by the coefficient of y prime and find y prime. So now you have, from this point on, even implicit differentiation, you may get terms which have exponential function or log functions in it, and you have to be able to use the differentiation rules. Any questions, any comments? So now we know how to differentiate log. We want to take another step. We want to use properties of log or ln to simplify some derivatives, some differentiations. In particular, as the first example, I'm interested in finding derivative of this function, x to the power x. I'll give you 45 seconds. I don't want you to write anything down. I don't want you try to show off, say, I know what to do there. I want you to talk to the friend sitting next to you and try to convince or start thinking together what would be the differentiation rule that I need to apply to find f prime for this specific function. What is differentiation rule that I can apply to find derivative of this function? And I'll give you 45 seconds. I want you to talk to someone. Don't sit there. Talk to someone. You're trying to convince each other that you know what to do.
How's your day been?
Talk. Twenty seconds left. Would anyone like to share their starting point with me or with us? The question was, what would be the differentiation rule to work with if we want to find derivative of this function? Does anyone want to share with us how you did that? Come on, please. Yes, please.
As if it's an exponent where the base is an Euler's number.
I see. So you're seeing this as x to the power n, yes? We call it power rule, yes? So in the power rule, then when you're differentiating, you get n x to the power 1 less. In this case, x times x to the power 1 less. Yes? What else? Did anyone do anything else? Any other rule? Yes, please.
Like e to the power of x ln x.
Or b to the power x, yes? So another way to see this maybe is this, yes? b to the power x, so base is b or x here. So I do ln b to the power x. Yes, do you have different? Yes, please.
Power of x.
Oh, you're seeing that as e to the power x?
Like e ln.
Oh, I see. Okay, let's keep that for a second. Thank you. That's definitely definitely. Or maybe what you were trying to say was also that one, but I heard what I wanted to hear. If you choose any of these ones, there is a serious issue with going with any of those two. Can anyone tell me what is wrong if I try to see this as this rule? Sorry, differentiating this as differentiating this one. Yes, please. Pardon? We'll get back to there, but for the moment, what is wrong if I see this as a special case of x to the power n, or power function? Yes?
It's meant to be like a constant.
Here, this rule applies only when the power is constant. And similarly here, the assumption is, or you can use this rule if the base is constant. So neither that nor that can be correct answer. Do I need a new differentiation entry in my table of differentiation? Not really. And I'll try to show you how one can use ln function, not any new differentiation rules, only ln function and properties of ln function to find derivative of that. That is the goal for me for the rest of today. So I have f of x is x to the power x, yes? You are interested in finding what? You're interested in finding what? F prime, yes? I won't listen to you. Instead, I will take ln of both sides. Why are you doing that? Because the complication of derivative of this guy comes from the fact that I have a function to the power another function. I can use properties of ln function and turn exponential into product. Remember the property? Ln of a to the power b is b ln a. So I can simplify this and write it as this. X ln x. Okay, after taking ln and simplifying, look here, I don't have any complicated term anymore here. This is just x times ln x. This is product rule. If I know how to handle product rule, I'll just go ahead and do it. Now, the next step is differentiate left-hand side, and it must be equal to the derivative of the right-hand side. Derivative of right-hand side, since it is simplified, only needs product rule, and that is derivative of first one times second one, plus the first one itself times derivative of ln x. What is derivative of ln x? No, louder. Derivative of ln x is 1 over x. That is derivative of right-hand side. Ha! Wait a minute. You're just trying to play with us. You change the function into an easier function, and you can differentiate that, but you didn't give us f prime so far. And I agree with that. That's why I have to complete this process. Now I have ln of something on the left-hand side. I want to differentiate ln of box. What is derivative of ln of box? Louder. What is derivative of ln of box? Thank you. F prime x over f of x. We were looking for f prime. Just solve it for f prime. In other words, just multiply the right-hand side by the whole f. This is 1 times ln x, which is just ln x, plus x times 1 over x is just 1. Yeah? Almost done. The only thing I would say to do, mathematically this is not adding anything, but I want to have explicit expression of x on the right-hand side. F of x is x to the power x. Just replace that or plug the value of f of x back on the right-hand side. The derivative happens to be neither this one nor that one, but the sum of those two. Where is it coming? That is the trick we are doing. That is the trick. This is a nice trick that help us to handle sum of differentiations, specifically the expressions like expressions that you can simplify after taking ln of that. X to the power x, if you take ln, you can simplify to product. So we are trying to use the properties of ln function and turn ln of your whole function to a simpler function, differentiate, and then try to solve that for f prime. Any questions? And yes, please.
Is x to the power of x not equivalent to the power of ln x times x?
That's right. That's right. You can use that method as well. But if you give me a few seconds, I'll tell you why do you need to know this whole method rather than just that specific formula that will work. Yes, it will work for these cases. Yes. Any other questions? Any other comments? Let's do another example, and then I'll write down. By the way, what I've done here has a name. It's called log differentiation. In other words, it's a derivative or a trick that uses log function to find the derivative, log differentiation. Find y prime if y is equal to x squared minus 3 to the power 3x squared minus 2x plus 1. Find y prime if y is defined as a function of x using that formula. $90 seconds? 90 seconds? Would that be enough? Would that be enough? Where are you guys? I need good yeses. Okay, 90 seconds, please. You're trying to see what is happening here and apply it on that specific example that we have up there. Go ahead, please. 90 seconds starts now. And yes, feel free to talk to the person sitting next to you if you have any questions. 30 seconds left. What would you then differentiate that? I see. The rule that this works for is when this guy is number. It won't work. Thank you. Yes. Okay. Let's see. The goal is, instead of right away taking the derivative, we try to first take ln, use properties of ln to simplify. Here, simplification will give me this. Yes? So I took the ln of both sides, simplified. Now I differentiate both sides. On the left-hand side, you will always get something like this. Y prime over y, f prime over f, or whatever the function prime over the function equals. Right-hand side is a simple thing to do now because it is just product rule, derivative of first one times second one plus the first one itself times the derivative of second one. Derivative of second one is ln box. Derivative of ln box is? I didn't hear that. Derivative of ln box is? Louder. Derivative of ln box is? Thank you. So what we found is y prime over y. To find y prime, I have to multiply this whole thing by y. And then there's a last step. I won't do it because there is too many terms there. I have to put back this guy into the y so that everything is in terms of x on the right-hand side. This trick is a useful trick not only for these specific cases, but other examples also this covers. I will, before I do another example to show you how properties of log and simplifying terms using properties of log can help us to differentiate a bit complicated functions, I want to rewrite the steps that we have taken in these two examples as a general statement. So this would be log differentiation. And I'm specifically interested in things like not only these ones, there are more other ones, but specifically it will work in this case as well. Step one was, instead of trying to differentiate right away, take ln of both sides. So d dx of left-hand side equals to d dx of right-hand side. That, oh, not dd, sorry, I meant to write ln of the right-hand side equals to ln of left-hand side. That's the step. That's where the log differentiation takes its name from. The second step is that simplify right-hand side or ln of right-hand side using properties of ln function. In particular, here I mean ln, for example, this is e.g., ln of f to the power g is going to be g ln of f. That's just one of the properties, yes? Step 3, differentiate both sides. And in particular, the derivative of ln y is going to be y prime over y. Yeah? Once you get to that place, then that's done. Step 4, solve it for y prime and replace y by the expression in x. So put this one back into the final formula that you have. These steps are telling me, in particular, how to differentiate these ones. The functions that are this form, a function to the power another function. I don't want you to use the final result of general fx to the power gx as an entry in your differentiation table. In other words, I want you to be able to run through these steps. When I'm asking you to find the derivative of a function like that, I am expecting you to go through steps like this or equivalent things like that. I won't accept it if you have an entry of how to differentiate f to the power x and you just write the formula down. I won't accept that. And one of the reasons I won't accept is here, I take this as an example of the log differentiation. The property we used here was ln of a to the power b is b ln a. There are also other properties of ln that can simplify things. For example, ln of ab equals to ln a plus ln b. Or if I have ln of a over b, then it would be ln of a minus ln of b. See, this turns exponential terms, function to the power another one, turns it to product. This property turns multiplication to addition, and this one turns quotient to subtraction. Compare the differentiation rules that you need to do these expressions to the differentiation rules that you need to do those differentiation. The right-hand side is way easier. And as an example, just to show you how this can help us to do more examples, find f prime using log differentiation if f of x is this expression, x to the power cube 3x minus 1 to the power 5. X squared minus 4x minus 1 to the power 3. Wait a minute, can't I just differentiate that expression using the standard quotient rule, product rule, power rule? Yes, you can. But there are so many terms, it will give you a long calculation thing. I want to show you through this example that this method would still work for some functions that we already know how to differentiate. But it will make our life easier if we use log differentiation. Okay? So I'll give you 90 seconds to go through these steps when you're dealing with this function. And the simplification that you will need to use are going to come from those last two properties of ln function. Go ahead, please, and I'll give you 90 seconds. Then I'll write down what is the answer there. 30 seconds left. Take ln of both sides. Then ln of this expression, there is this times that divided by that. So I can say ln of this guy plus ln of 3x minus 1 to the power 5 minus, in the denominator, ln of x squared minus 4x minus 1 to the power 3. I can actually do one more simplification. This 3 can come up right there. That 5 can come down, and we get this one. And that 3 again will give me that one. So this is ln of f of x. We simplified. Compare this expression to the expression that we started with. Over there, I needed to do power rule, product rule, quotient rule. Here, this is just sums of some functions. And I can go ahead, derivative of the left-hand side is f prime over f equals derivative of right-hand side. 3 times ln x. Derivative of ln x is? Derivative of ln x is? 1 over x. 5 times derivative of ln box. It is box prime over box minus 3. X is 2x minus 4 over x squared minus 4x minus 1. Yeah? And then the only thing is left is I write f prime, multiply f to the right-hand side, which was x cubed 3x minus 1 to the power 5, x squared minus 4x minus 1 to the power 3, times 3 over x, 15 over 3x minus 1, plus 6x minus 12 over, sorry, this is minus, x squared minus 4x minus 1. Yes, you could have done differentiation of this one and just using the regular derivative differentiation rules that we had. But try to do that one without log differentiation, and then you will come back, and I'm sure that you will appreciate how log differentiation can simplify things. And by the way, at the end, turning that derivative of that to that expression would be very painful task to complete. Yes?
Shouldn't it be plus negative 3 times negative 4? No, but
I multiplied 3 inside. I kept the negative outside. Yes, yes. Any other questions? Any other comments? It seems you survived today. You learned more things, hopefully. You come back tomorrow. We will start new section. We will do more stuff. Have a great day and see you all tomorrow.